Hi, my name is Mr. Evangelista, and welcome to another episode of Evangelista Science. We're going to today continue our lecture on Chapter 9 of the I Became a Cell curriculum, talking about redox practices. Okay? So, what we're going to look at today is writing redox equations, and particularly balancing the equations. Now, it's kind of like how we would normally balance equation, but there are a couple tips and tricks that you have to keep in mind. And so, if we look at this, let's start off with a problem. Write an equation for the reaction in which the nitrate ion and copper react together in acidic solution to produce nitrogen monoxide and the copper 2+ ion. And so here is exactly just written in equation form with the problem asked for. And so far we've been assigning oxidation numbers to these. So nitrogen is +5, copper metal is 0, nitrogen and nitrogen monoxide is +2, and copper ion is +2. And so we can see that nitrogen is going from +5 to +2, and so it's gaining 3 electrons, so that's oxidation. And copper is losing 2 electrons, and so that's reduction. Okay? So we're good so far. And so we have to follow the steps on your screen in order to actually balance these redox equations. So we just assigned the oxidation states, that's fine. Now next, for number 2, is the big part. We got to write the half equations. We got to balance the atoms, and then we are going to add water to balance oxygens. Then we're going to add hydrogens to balance the H's. And after that, we're going to add electrons. And then after that, we're going to multiply the half equations to balance for atoms and for charge. This might seem a lot right now, but hopefully as we go through an example, it will all make sense. So let's take a look at this example that we just looked at. So here is my oxidation and my reduction. I have broken them down into their half equations. So I've written the oxidation reaction and the reduction reaction from my kind of parent equation here. I just pretty much just took the nitrate becoming nitrogen monoxide and the copper becoming copper 2+. And so the first thing I want to do is make sure that everything is balanced. And so right now I have 1 copper on the left, 1 copper on the right. That's good. I've got 1 nitrogen on the left, 1 nitrogen on the right. Good. The oxygens and hydrogens you don't have to worry about balancing right now, because that's going to be the next step. The next step is to add water to balance any oxygens. You'll notice that on this side I don't have any oxygens, so I don't need to add any water. However, on this side, I have 2 more oxygens on this side than this side, so I'm going to have to add 2 water molecules to the right side. Now the oxygens are balanced. Next, what I'm going to do is I'm going to have to balance the hydrogens, and the way I do that is with the H+ ion. So no hydrogens on this, so I can leave that one alone. I have 4 hydrogens on the left, so I'm going to add 4 hydrogens on the right. Now the next step is the electrons. Now these electrons come from when I defined how many electrons the oxidation and reduction reactions are occurring. And so we said that the copper lost 2 electrons, and we said that the nitrogen gained 3 electrons. Okay. Now, the amount of electrons lost needs to equal the amount of electrons gained. So this number here needs to equal this number. So I'm going to need to multiply these equations by an integer to make sure that the amount of electrons is equal on both sides. So for this oxidation, the least common denominator of 2 electrons and 3 electrons is 6. So I'm going to need to multiply this equation here by 3. And that will give us 3 copper equals this. And then I'm going to need to multiply this equation by 2. And that will give me this equation here. Now all I'm going to do is I'm going to add the 2 equations together. So I'm going to add everything to the left of this arrow of this equation with everything from the left of the arrow from this equation. And I'm going to add everything from the right of this arrow from this equation with everything from the right of the arrow of this equation. When I do that, you'll notice I have the 3 copper here, the 2 and the 3 here, the 8 hydrogen there. Now what happened to the 6 electrons? Well, since I have the 6 electrons after the arrow and 6 electrons before the arrow, those cancel out. That's why you need these to be equal. Okay, so everything is there. 3 copper 2 plus is after the arrow. That's good there. 2NO is after the arrow. That's good. 4H2O is after the arrow right there. Okay, and that's how you write a redox equation. A little bit more complicated than just simply balancing an equation, but if you follow the steps that I showed you, you'll be okay. So balance the atoms other than hydrogen or oxygen. Add water to balance the oxygens. Add hydrogens to balance the H plus to balance the hydrogens. Write in the amount of electrons gained and lost. Multiply if you need to so that the electrons are the same, and then add the two equations together.